Welcome to Calculus in the PM. I'm your host, Mr. Shadelka. We're going to look at derivatives of trigonometric functions. And do you guys remember what's happening to Sears? It's closing. So guess what? Our new message is from the old Sears Portrait Studio. One last time, you can go in to get your portraits. And there we are. It was come on down, and it's a one last, you got till December to get your portraits done. One last package. We got various things. You come in and see us. Now, trig functions. The first thing we're going to do is sketch. And we've actually done this before, but what does the sine of x, what is its derivative? Because you can't do this like using the rules with exponents, x squared and stuff. And yeah, you already know it's negative cos. How could you tell?
It's like with the slopes, if you actually draw out the slopes.
Exactly. So we're going to do a quick rough sketch. As Corey mentioned, by looking at the slopes of the tangent lines, it suggests negative cosine function. I have a hard time drawing this on the board. That's not too shabby. So, oh, why didn't I? Yeah, yowzers, eh? It isn't negative cos, that's why. What does this look like? It's cos. Okay. Hey, he was trying to do it in his head, and he did it. It was a cosine function, but it was not negative. It looks like the cosine function, sideways C. Yeah. Okay. So, what does this tell us? The derivative of the sine function is positive cosine of x. That's what we have, not negative cosine. But hey, we drew it and found out whether he was right or not. Thank you for guessing. Even. Most people. Okay, now, with the cosine function, we're going to do the same thing. Now here it looks like it would be a slope of 0, right? So I put a 0 here. Here it looks like it would be a slope of negative 1. Zero at pi. Positive 1. And 0 again, you can see as it. We'll hold our answer until we take a look at the full picture. I don't know. What is it? I'm just going with your answer. You said negative sine. Is it negative sine?
Yes.
Yeah, it is. Okay.
That's where my negative is.
That's where your negative is. You were looking down. He's working ahead. If you can do this course without making mistakes, you're wasting your time in high school. So, the derivative of the cosine function is the negative sine function. Hey, this is like cyclical almost, like as in, then if you did the derivative of the negative sine function, you'd get a cosine function out of it, but it would probably be negative cosine. Then it would be negative. But then if you did the derivative of that, do you see how you're going to just go back and forth between sines and cosines? Okay. Anyways, this is not a proof. This is just what it suggests. Now, I only bring this up. I have it on paper. If you wish to examine it, there is a proof. It isn't witchcraft, and this is the actual proof of why we got the results we did. The derivative of sine is, so if the function is sine of x, the derivative is cosine of x. Now, it involves some of the limits we saw before, like, see that on the poster there? Sine of h over h, where it's approaching 0. It involves that. I'm not going to go into this, though, okay? What you need to know is these two net results. Commit to memory. Like I said, we already saw that on this. Okay? Now, I also have something here. I say today, don't worry about this until we've done something about the chain rule next chapter. But memorize, memorize. You will. The derivative of sine of x is the cos of x function. The derivative of the cos of x function is negative sine of x. We'll get that in our head, not so much by memorization, but by using it a lot. Okay. I have the answer given here, so why do we even have to do this? He gave us the answer. Oh well, we'll do it. Find the derivative of this function. Okay. Why don't we call this f of x just so we can use notation we like? And so I'll just say it's equal to f of x. And let's see here. So f prime of x. What kind of rule do we have to use here? Product rule, what? Quotient rule. So that's the derivative of the top, leave the bottom alone. So the derivative of sine of x, cos of x. We just learned this. Write down the bottom.
Unit 6 last year makes sense now.
It's all coming back to you. Unit 6 works. Okay. Subtract. That subtract is built into the formula. The top thing left alone. The derivative of the bottom. Cos of x's derivative, negative. Then the minus 2 part, 0, right? Okay. The bottom, the denominator, squared. We just applied the quotient rule. We haven't simplified anything. We could tell anything in red was from the numerator originally. Anything from blue came from the denominator, right? Okay. Then from here, what do you notice about if I distribute the multiplication here?
Cos x squared.
Cos x squared, okay. I'm going to drop the color scheme. Cos x squared. You guys said it that way, but I'd say cos squared x. That's the norm for writing. If you do it the other way, do not do this. Because that means the x squared. If you want to do it the other way, do it this way, right? That's what that means, but you'll never see it, well, rarely see it that way, okay? So the cos squared, you guys, you're familiar with this notation. I know that. Minus 2 cos x. Subtract, well, really it's add, negative, negative, sine squared x. All over the denominator. Cos of x minus 2. Keep it squared. Keep it real. Now, I mentioned before that you should know the Pythagorean theorem, or identity. Just because these aren't beside each other, what's cos squared plus sine squared? 1. You see where this comes from? 1 minus? Nothing happens here. Now, that 1 is portable, it's commutative. You're going to have it plus 1 at the back end, or 1, positive 1, minus the 2 cos x. So that's where you get the answer that was desired. Okay, which one? Sorry? My square there is built into the line, but which question? Sorry, which part? Okay. If I wanted to, I wonder if I have these all stuck together. Okay. Would this make sense if I didn't have the equal sign? I put this behind here. Is it still the same? Plus cos x, cos squared x? What's sine squared x plus cos squared x? 1, okay. So, I could think of this numerator then as negative 2 cos of x plus 1. You agree with that? Okay. And the plus 1 is commutative. As long as you keep the signs attached to the minus 2 cos x, I can put the plus 1 at the front. That's what we're doing. Okay? And that's where that comes from. Okay. Then, I will just take a look at this example here, and then we'll was an equation to the tangent line of this graph, y equals x plus cosine of x at the point 0, 1 is a, b, c, d, e. I don't know. See, you can guess. What don't we do instead? Find the derivative. Because we hear the word tangent line, you're probably thinking you need a formula for the slope of the tangent line. Okay. So y, and I gave you a function that you probably wouldn't graph right at the top of your head. It requires some thought. Okay, so if this is y, you need the derivative. Good. So y prime, I'll use that instead of dy today. The derivative of x is 1. Cosine of x is negative. Subtract sine of x. Okay. Then I am talking about the equation to the tangent line at 0, 1. So what do I do to find the slope? Well, what's the x value you're interested in for the slope? 0. So I'm going to just take this, plug in 0, 1 minus the sine of 0, which is 1 minus, what's the sine of 0? 0. Yeah. If you're ever confused, just remember the sine, well, it's all drawn up on. But like, if you're evaluating sine of 0, pi halves, and you're like doubting yourself, you know that sine is like a sideways s, right? At 0, what's the value of sine? It is 0. Likewise, at pi halves, it is positive 1. And you could just think it through if you need to verify your thoughts, if you're guessing, second guessing yourself. Y prime, the slope at 0 is equal to 1. Slope of the tangent. Okay. I got the slope of the tangent line. I almost don't have to do much, but we will. I can eliminate this because it's definitely not 2 and it's definitely not. So that's what we do now. Y minus y1, positive 1, equals m x minus 0. Now, I think, I'll just move this out of the way. If you want to, if you can't quite do that in your head, you could probably guess already, but y is equal to, because, yeah, x plus 1. Okay, there you go. B it is. Now, if you're doing multiple choice, I would advise you to do as many shortcuts as you can without being sloppy and making mistakes. If you could see the answer right here, I wouldn't take the time to do this. I'd just jump straight into your answer. If you know you're prone to make mistakes, though, do it, and then get your answer. No use being fast if you're getting half of them wrong, or making a mistake every 10 questions even. Now, has some other stuff after that, but I'm not going to get into it right now. I'm thinking you guys could try some of these problems here for the next 15, 16 minutes. Which problems you say? Oh, here it is. On page 146. Let's just see today what you could do with these. Find the derivative. Okay. Yeah, 1 looks good. 2 looks good. I got even answers given there too. Four looks good. Oh, no. Skip 4. So 1, 2, like we'll skip it till after, because we haven't done them all. So right now, 1 and 2. Ooh, I can't do 2 because it has tangent of x. I'm trying to just keep sines and cosines here. I'm trying to be nice. Okay, 6. Nope. 9. Nope. 10. Yep. So you can do 1, you can do 10. In the next few minutes, 21. 21. By the way, for 21, I'm not really worried about the normal, just the tangent line. '29 looks good. That is great, actually. That is good. Those 4 questions should be good for today. The other questions you'll come back to, but they involve the other trig functions. I didn't want to start on that today. Okay? Now I should pause this. I forgot to.